Today's lesson, we're going to do alternating series, and these are series that both contain positive and negative terms within the series. They're actually alternating positive and negative, and we're going to see um, when they converge. So the alternating series test says if you have an alternating series, whether it's either positive, negative, or negative, positive, negative, it converges if two of the following conditions are met. And that is the limit as n goes to infinity of a of n is equal to 0, and the second term has to be less than the first term for all terms. If those two conditions are met, then the series converges. So for example, summation of n to the 1 to infinity of negative 1 n plus 1 over n. This negative 1 n plus 1, that's my alternating. That means that one term is going to be positive, the other one's going to be negative. So when n is 1, notice that this is 0, so it's positive, so I get 1 over 1. When n is 2, we have 2 plus 1, which is 3, so it's odd. So this is going to be negative, so I have 1 minus 1 half plus 1/3 minus 1/4 plus 1/5. So they're alternating, they go back and forth. So what we need to do in order to do the alternating test is we need to find the limit as n goes to infinity of 1 over n, right? This is a sub n. And notice that that is equal to 0. Because as the denominator gets larger, my series goes to 0. So the first condition is met. The second condition is I need to make sure that 1 over n plus 1, so you're going to have n plus 1, is less than 1 over n. And that is also going to be true because notice that the left side, the denominator here, when I add 1, it's always going to be bigger than n. So the denominator is bigger, so that means this is always going to be smaller than 1 over n. So therefore, by the alternating series test, this series converges. Okay. So this converges because it's the a sub n is equal to 0, and the second term is less than the first term at all the time. So notice that the absolute value of negative 1 over n plus 1 times 1 over n would be 1 over n. This is a p series. Okay. So this is a p series when n where p is equal to 1. So this series actually diverges. So the absolute value diverges. So what we do is this is called conditionally divergence. Sorry, conditionally convergent. So this is called conditionally convergent because my series is the alternating series does converge, but if I take the absolute value, it does not. It diverges. So this is conditionally convergent. It would be absolutely convergent. So it would be absolutely convergent if the absolute value and the alternating series converge. So it's conditionally convergent. So it's absolutely convergent if the so if the absolute value converges, then we say the series converges absolutely. If the absolute value converges of the series, then this is automatically going to converge. So A sub n is conditionally convergent if A sub n converges by the absolute value diverges. Okay, so if the series converges absolutely, then the series is going to converge. So for example, determine the convergence or divergence of the series. Notice that the absolute value, just so you guys know, the absolute value of this series is 1 over n squared. So it's a p series. It's a p series. P is equal to 2, which is greater than 1. So this converges okay, absolutely. So if my absolute value series converge, so is the alternating series. So I don't have to use the alternating test for this. I could as well. So there's two methods that you can do. Remember, the alternating series says that the nth term has to go to 0, which it does, and my second term has to be less than the first term, which they are. So therefore it converges. So this converges absolutely. Okay, so for this one, first we're going to change it. Notice that this is my alternating. So I'm going to rewrite this to just so you guys can see. We're going to rewrite this as -1 times 2. So using rules of exponent, we're going to have -1 to the n minus 1 times 2 to the n minus 1. So there's my alternating series. So this is okay, so here's my a sub n. So we're going to use the alternating series test. So we want to know the limit as n goes to infinity of n over 2n minus 1. So notice that when n is infinity, this goes to infinity. 2 to the infinity minus 1 is 2 to the infinity, so that goes to infinity as well. So we're going to go ahead and use L'Hopital's rule. So we're going to take the derivative of n. Sorry. The derivative of 2, n minus 1 is ln of 2 times 2 to the n minus 1 times the derivative of n minus 1, which is 1. So notice now, as n goes to infinity, this goes to infinity, which is 0. Okay. So the first part of my alternating series test checks. So now I need to make sure that my n plus 1 term is less than my nth term. So if you notice, okay, my first term is going to be 2 over 2, which is 1. And then this side is going to be 1 over 1. So it's less than or equal to 1. My second term is going to be 3 over 4. And on this side, I'm going to have 2 over 2, which is 1. So 3, 4 is less than 1. My third term, I'm going to have 1/2, which is less than 3/4. So as you keep doing this, you're going to see that this term is larger than the n plus 1 term. So therefore, this series converges by the alternating series. So we have an alternating series. So we're going to need to check both my nth term. So notice that that's equal to 0. So now I need to make sure that the n plus 1 term is smaller than the n plus 1. So notice in this case it will, because the denominator here is always bigger by 1. So my nth terms is always going to be bigger than my n plus 1 term. So this series converges by the alternating series test. Notice also so we're going to use the alternating series test. So we need to check when it goes to infinity. So notice I get indeterminate, I get infinity over infinity. So I'm going to use L'Hopital's rule. Which is equal to 1. So this does not equal to 0. So I cannot use the alternating series test. But because the limit is equal to 1, I can use the nth term test, right? Which says that if the limit is not equal to 0, the series diverges. So by the nth term test, I know that the series diverges. So one of the things about the alternating series test is that we can find what the sum of my series is. For a convergent alternating series, the truncation error is less than the first missing term and it's the same sign as that term. So basically what it means is that if you're trying to find the sum is somewhere between the last term that you found plus or minus. And it's hard to see it in this, so we're going to do an example. So we're going to approximate the sum of the series by using the first 6 terms. So you're going to write the first 6 terms, okay, the sum of the first 6 terms. All right, so this is going to be approximately 2.7067. And the 7th term is approximately 1.9235. So that means that my sum is going to be somewhere in between 2.7067 plus 1.9235 and 2.7067 minus 1.9235, which is not a very accurate sum because I'm going to have 0.7831. So my sum is going to be somewhere between 0.78 and 2.7067. So this is not a very accurate sum. So in order to get it more accurate, we would have to use more terms. The more terms we use, the more accurate my sum is going to be. So we can get an error sometimes of less than 0.01. Another way we can do this is by using our calculator. Come in here. So I'm going to put my, notice that it's in terms of x. So I'm just going to put that in here. So if you go to your home screen, under Math, there's your summation, number 0 is your summation, press enter. So I'm going to go from x, from 1 to 6, remember we're adding 6 terms, and then I'm just going to put my 1 variable in there. Okay, so we got 2.706721, and that's what we got by doing this by hand. So notice that the best term would be if you number of terms required to approximate the sum of a convergence here was an error of less than 0.01. So basically, when you're doing these sums, you want to have an error of less than 0.01. So what you have to do is you kind of have to do, okay, what is my, let's say, fifth term. So you find your fifth term. So I'm going to use my calculator for this. And what you do is you're trying to find a term that the sum is less than 0.01. So I'm going to use my calculator. And your factorial button is in your probabilities. So there's my term. So what I'm going to do is I'm going to find I'm going to start with my third term. So I'm going to say calculate substitute 3 into y1, and I want the decimals. Okay. So notice that the third term is -4, so the third term is going to be 1.984, and then we're going to move the decimal 4 times. So remember, we wanted an error of less than 0.001. So this can work. So we can do S of 3. Okay. So that means that we're going to sum the first 2 terms. Okay. And then my error is going to be 0.001984. Okay, so there's my summation of y1, first 2 terms. Okay, so I get a negative 0.01120, which, do it in decimals. Okay, so there's my summation. So I'm going to go ahead and store this in A. And if you remember your third term, and I'm going to store this in B. Okay, so just to give you an idea of what we were doing, okay, we summed the first two terms of my series using my calculator, and that was negative 0.84167. Okay. The third term is approximately 0.0001984. So according to my summation, my sum is going to be somewhere between, when you add the third term and you're going to subtract the third term. Okay, so that is what your sum of your series is going to be. It's going to be somewhere between here and there. So if we do this on our calculator, okay, so the sum of the series is going to be 0.8414 and 0.8419. So the sum is going to be somewhere between these two. So the sum is actually 0.841470. Remember how we said it was sine of 1? So we're really close to those two. The only thing that we forgot to do is we forgot to do the absolute value. So it should have been the absolute value of my term. So that's how we get the positive. So the actual answer is sine of 1. So my sum is going to be somewhere between 0.8414 and 0.8419. Remember, we always take the absolute value, which is really close to the actual answer.